So we have this thing called a reciprocal, which basically takes a trig function and turns it over. So if I had sine, its reciprocal is 1 over sine. And we've defined that to be this word cosecant of theta. So we just know when we see cosecant, we could write it as 1 over sine. Likewise, if we have 1 over cosine theta, that is the secant. And it's opposite of what you think. The C's and S's go together, which is just a different way of saying it. But the co means something in geometry. Complementary, co-complementary means they add to, excuse me, add to 90. So that being said, that's why. Doesn't explain it very well, but it gives you some vocabulary to it. And then if I have 1 over tangent, that's equal to cotangent of theta. So those are called the reciprocal identities. We learned way back in the first couple discoveries of this thing called Pythagorean, which had to do with the right triangle that said the legs squared added together equal to hypotenuse squared. And we cut out this triangle and put it all together and saw that if I had a square cut out on one leg and a square on the other, they would form a square off of the hypotenuse. And so that also works here. So we're going to put a triangle in this circle. This distance we don't know, it's x, y, and 1. So because this is a right triangle, this same idea would work. X squared plus y squared equals 1 squared. Well, from earlier, if I take a look at this, the sine of this angle is y over 1. The cosine of that angle is x over 1. So if I replace the equivalency of y for this triangle with a trig function, means I will put a sine there. And likewise, if I take x on this triangle and replace it with its trig function, we'll get what we call the Pythagorean identity, which says cosine squared of theta, which is the x, plus the y, which is sine squared theta, equals 1 squared. Recall that we can write a square in a little different location. Excuse me, but it means the same thing. So this is sine theta squared. I better rewrite that. And lots of times we'll just say 1 because 1 squared is 1. So what we're going to do is kind of mess around with these just a little bit. I could take it and divide it all by cosine squared theta. So I'm going to take my cosine squared theta plus sine squared theta and divide it all by cosine squared theta. That seems odd. We actually call this a cousins. This is equal to 1. From my definition above, sine squared over cosine squared is tangent squared. There's a plus sign there, and that's equal to, if you look at that, that's equal to secant squared. So that's one of the cousins. There's another cousin. Instead of dividing by cosine squared, I could divide by sine squared. So I'm taking my Pythagorean that we proved above, and now I'm dividing everything by sine squared. And if we take a look at that, this is equal to cotangent squared plus 1 equals cosecant squared. And all it just has to do with those definitions.